Hello and welcome to part 1 of an unbelievably cringy set of videos on computer systems and things. I will be your narrator and future me will hopefully be editing in any information that I happen to miss out on, seeing as you, bright ideas, are, in fact, a video making company. I can imagine that you're already judging the quality of the images and flow. Just a quick note about that, it sucks, I know, bear with me and at least try to listen. So what are we going to be discussing in this video? Well, I'm going to try explaining to you the different hardware components in your computer and what they all do in order to allow you to make the most out of your money when buying your computer systems for your company. For semi-educational purposes, and because I've been told to, by you, I've decided to provide some images myself from my personal computer. This is in order to show you where each component generally lies within your average desktop computer. As a quick note, to open said computer, I unscrewed 4 bolts at the back in order to take off the casing, and then I lifted up some weird bridge-like thing. I really don't know why you would need to know that, but blame your manager. As another note, expect abbreviations, many of them. Just stick to the main component names and you'll be fine. Hopefully. So let's start off with the BIOS, or in inconvenient terms, the basic input-output system. The BIOS is the device in your computer that is responsible for the entire startup sequence that your computer goes through until the operating system is booted. The sequence goes a little like this. Firstly, the BIOS communicates with the CMOS, that is, the complementary metal oxide semiconductor. It stores startup information, from which the BIOS gets the various computer settings such as the time, the date, and information as to how the various other devices, like the hard drive, are first loaded onto the computer. The BIOS then loads up interrupt handlers to manage any instructions that are sent to the processor before loading up various drivers for any devices that are connected to the PCI slots. By the way, PCI stands for Peripheral Component Interconnect. Don't ask me why, it just does. After this, the BIOS initializes the registers, which is the processor storage area, sets up the power management for the computer, and does the post. No, not that post. And not that one either. No, I mean the power on self-test. Whoever's editing this is a right loser. Oh, right. So what the post does is it checks all of your hardware is in working order before the BIOS can proceed to display the system settings from your monitor, determine which devices are bootable, and initiate the bootstrapping sequence. So what the bootstrapping sequence does is it gives the address of the operating system within the hard drive to the processor along with the instruction to boot it up so that the processor can, well, find it and boot it up. So that's basically the BIOS. Well, actually that's pretty difficult to follow, so here's a simpler way of putting it. The BIOS is the device in your computer that is responsible for the entire startup sequence that your computer goes through until the operating system is booted. The sequence goes a little... Basically, without it your computer wouldn't even be able to start up, so I'd say it's a pretty important device that you'll need for your computer. Fortunately, most computer BIOSes are generally around the same and don't really hold much impact on a computer's performance after the operating system's been booted, so you don't really need to take this component into consideration when you're buying your new computers. That's right guys, I've just wasted 5 minutes. Seeing as you're all probably annoyed at me for wasting your time just then, here's a component that it may actually be useful for me to talk about. The processor, or CPU. That's the central processing unit, because CPU. Get it? The processor is effectively the mother brain of your computer. Or maybe just brain. It contains various inbuilt registers including a program counter, a memory address register, a memory address buffer, an instruction register, an arithmetic logic unit, and a control unit. So pretty much all of these, with the exception of ALA, take part in a little cycle called the fetch and execute cycle, which allows the CPU to receive instructions from around the whole computer and to execute them. It goes as follows. I hope you've been keeping up with your abbreviations. Okay, that is getting cut out. The address of the next instruction for the CPU in the book is sent to the MAR, where the control unit reads it and fetches the instruction from the read address, which could be from the HDD, the ZUD, or the RAM, or anywhere else for that matter. The instruction is fetched and then sent and moved to the MAB and ER respectively, where the control unit advances the book to store the address of the next instruction. In simpler terms, the processor does rather a lot of work lugging all of the computer's many requests and instructions from around the place in order to execute them. Basically, without it, all your computer would be able to do would be to send instruction addresses around the place, which is the equivalent of folding up an instruction manual into paper aeroplanes and throwing them around the place. Sure, you get stuff happening, but, I mean, you kind of want to build your IKEA table. Not that I use IKEA. Maybe. When getting a processor, you're going to want to focus on getting a large number of cores and hertz. More cores means the processor can do more tasks simultaneously, and the more your processor hurts, the more it can empathize with your drinking problems. So, yeah. Next. The RAM, or the random access memory. The RAM is effectively the in-the-moment memory of your computer. The RAM holds temporary information for your computer through caching. Don't ask me what that is. I'm not being paid enough to go into that. And the RAM then provides that information to the processor. The RAM is also completely wiped every time your computer is turned off. The random access bit means that any memory cell can be accessed directly, providing that the address is known. This is as opposed to SAM, where you need to slog through the whole set of information just to find the bit that you want. Kind of like when you fast forward through the whole of Titanic just to find... Oh wait, there are no good scenes in Titanic. That was not a laugh. Anyways, all you really need to know is that the RAM is a pretty vital piece of equipment, because without it your computer would have to physically store all information on the hard drive before reaccessing it and deleting it, which would mean your computer would take about 20 times longer to do just about, well, anything. Oh, and when looking for RAM, you're looking for the gigabytes. Average computers have around 4 to 6 gig of RAM, normally from 2 gig RAMs or from 2 3 gig RAMs. But if you want to go all out on your animating, then I would recommend at least 6 to 8 gigs, if not more. As a quick note, most RAM is DDR. That's double data rate, not... well... yeah. Which means that it can transfer data at both ends of the clock cycle. You should get DDR RAM because it transfers twice as fast as not DDR RAM. The hard drive, or the hard drive. The hard drive, as opposed to the RAM, is more like the long-term memory of your computer. It stores all of the information put into it physically as cache, not to be confuddled with caching, for the processor so that it doesn't end up wiped whenever the computer is switched off. This means that it takes much longer to transfer data than the RAM, because each piece of information has to be physically stored or read off the system. The hard drive is especially important in your case because without a hard drive you wouldn't be able to save anything at all, which may possibly just cause some problems in regards to the videos you make. When looking for hard drives, you're going to want to look for how much it can store. I would recommend around 500 gigabytes to 1 terabyte, and it may also help to invest in a solid state drive instead of your regular hard disk drive, because although you can't get as much storage on it as from a HDD, and it's much more expensive, a SUD is much faster and so may help with company efficiency. The Network Interface Controller, or NIC. The Network Interface Controller can connect your computer to various networks such as Wi-Fi, Ethernet, or local computer networks if you're planning on connecting your computers together at all. The NIC isn't really vital, but without it you wouldn't be able to access the internet for business purposes. Oh, I mean business... Wait, is that it? The graphics card. This is effectively a mini circuit board that's attached to your computer's main circuit board that's designed to deal with all instructions related to monitor input and output. Most processors are designed to handle monetary things, so these aren't really that necessary to most people, but seeing as you create videos, you're going to need a fairly decent dedicated graphics card. When I say dedicated, I mean it has its own RAM and it's not just using up the rest of your computer's RAM. Sorry, I meant the RAM. I would help you with what you should look for when buying a graphics card, like the amount of dedicated RAM you should get, but graphics cards have so many different variables that contradict with each other that you're better off just going on GameDebate.com and looking up stuff on there. Is that all? Again? Well, okay. The sound card. A sound card is effectively a graphics card, but with the job of handling sound instead of the visuals. So just rewatch the last 2 minutes and replace the visual stuff with audio stuff. Oh yeah, take the game to bit out too. Game to bit? Game debate bit. Oh, yeah. They do sound cards. Wow, that was even shorter. I guess my scriptwriter's like my local doctor then. He's running out of patience. He's running out of patience. The power supply unit, or PSU. The power supply unit provides the electricity from your plug socket. Oh yeah, you'll probably need one of those too, to both the motherboard and each individual hardware device connected to your computer. If you don't know why an electrical power supply unit might just be useful on an electrically powered computer, then just who hired you? Also, can you hook me up with them? I'm kinda looking for a job right now. And raisins! The various computer connections and slots. Slots. There are 3 types of connections or slots for your computer. I shall run through each of them as fast as I can whilst sitting down. Peripheral component interconnect slots. These are the slots in which you plug all of your various cards, like your sound and graphics cards. These slots are a dedicated route, and so only one card can be plugged into each individual slot. There are 3 types of slot, aptly named 1.0, 2.0, Express, and 3.0. Express, which transfer data from the cards at a rate of 250 megabytes per second, 500 megabytes per second, Express, and 1 gigabyte per second, Express, respectively. Note that 3.0 Express slots are still in development, so if you're going for that option, then I wouldn't expect an Express delivery. Data connections. These connections transfer data. That is literally it. There are 2 different types of data connections, and both of these are parallel transfer methods. This means that information is sent down multiple wires at once so that more can be transferred in a set amount of time. The first type are the IDE connectors. These connectors have 40 pins, a data transfer rate of 133 megabytes per second, and a 5-volt power consumption. Also, only 2 connectors attached to 4 drives, that's 2 primary and 2 slave, can be used for each computer. The second type of connectors are the SISI connectors. These normally have either 50 or 68 pins, a transfer rate ranging from 150 megabytes per second to 6 gigabytes per second, and a 250 millivolt power consumption. Also, they are thinner and longer. They do not require software-based drivers to run. Up to 16 cables can be used per system, and they allow for hot swapping. Pretty sure some of that grammar's wrong. Whoops. Okay, so you didn't really need to know any of that, but I've got a time gap to fill. Here's a simpler explanation. Get sissy cables for not so sissy results. Internal and external power connections. I'm presuming that you all remember what I said in the power supply unit section. Good, now let's see what the different cables are. The floppy drive connector, it has 34 pins. The Molex connector, it has 4 pins and is used for CD, IDE or other drives. The SATA power cable, it can deliver up to 3.3 volts of power to your computer. Wait, what? The PS2 connector, no relation to Sony. This is used to connect your mouse and keyboard to your computer if it so happens that you're an avid protester of USB ports. The VGA, this has 15 pins and connects to the monitor to display visual output. The DVI, this has 18 pins and does the same job as the VGA, but better. The HDMI, this has 19 pins and connects to the monitor to display visual output in 1080p. And finally, to end it all, the Centronics parallel port connection. This has 36 pins and is used to connect your computer to printers and other external devices. Well, that's it for this video. I hope that you thoroughly enjoyed. Learnt a great deal from this experience, of course. I would say something else more productive right now, but past tense script writing me is up past his bedtime and his parents are lecturing him on the importance of sleep and... Wait, how did I even write this without looking at the screen? Anyways, see you in part 2 for operating systems.